95 million years ago, in what is now the Sahara Desert, a predator unlike anything before or since stalked the rivers of North Africa. It had the jaws of a crocodile, the sail of a reptile no one had ever seen, and a body built not for the plains, but for the water. This was Spinosaurus aegyptiacus, the largest predatory dinosaur ever confirmed to have walked and swum on Earth. Longer than a Tyrannosaurus rex, stranger than anything Hollywood could invent, and almost lost to science forever. This is the true story of Spinosaurus, pieced together not from imagination, but from bone. Our story begins not in a museum, but in the Egyptian desert in 1912. A German paleontologist named Ernst Stromerr von Reichenbach was working in the Bahariya oasis when local fossil hunters brought him a set of strange bones. A long, narrow snout lined with conical teeth and towering neural spines unlike anything catalogued before. Stromerr named the animal Spinosaurus aegyptiacus in 1915, spine lizard from Egypt. The bones were shipped to the Bavarian State Collection of Paleontology in Munich, where they were assigned the specimen number BSP 1912-819, the original holotype of Spinosaurus. Even from this first partial skeleton, a lower jaw, vertebrae and rib fragments, Stromerr recognized something unusual. The teeth were straight and round in cross-section, not the serrated blades of a typical theropod. This was a fish-eater's mouth, not a flesh-tearing one. But then came a war. On the night of April the 24th, 1944, Allied bombers struck Munich. The Bavarian museum housing Stromerr's specimen was destroyed. The only Spinosaurus skeleton known to science was reduced to ash and rubble. For over 60 years, paleontologists had nothing left of Spinosaurus but Stromerr's drawings, photographs, and written notes. Spinosaurus became a ghost, a dinosaur known only from a memory of bones. Decades passed before Spinosaurus fossils resurfaced. In 1996, Italian paleontologists Cristiano Dal Sasso and Marco Signore described a new partial skull recovered from Morocco's Kem beds, a region that would prove to be a gold mine for Spinosaurus material. In 2005, this specimen was formally designated the neotype of Spinosaurus aegyptiacus, catalogued as MSNM V4047 and housed at the Museo di Storia Naturale in Milan. This skull confirmed what Stromerr had first suspected: an elongated, crocodile-like snout, a secondary palate strengthening the jaw against twisting prey like fish, and small openings called neurovascular foramina running along the jawline, the same sensory pits found in modern crocodilians, used to detect pressure changes in water. For years, though, most of the skeleton behind that skull remained a mystery. Scientists were essentially trying to describe an entire animal from a face. That changed with the discovery that would rewrite the Spinosaurus story completely. In 2008, paleontologist Nizar Ibrahim tracked down a local fossil collector in Erfoud, Morocco, who had sold pieces of a partial Spinosaurus skeleton years earlier. Piece by piece, Ibrahim and his team reassembled the story of where those bones had come from. A single locality in the Kem beds, known as the Zregut site, dated to roughly 95 million years ago, during the Cenomanian stage of the late Cretaceous. This new specimen, catalogued as FSAC-KK11888, housed at the Faculté des Sciences Ain Choc in Casablanca, became the most complete Spinosaurus skeleton ever assembled. Published in Science in 2014, it revealed a body plan unlike any other large theropod dinosaur. The proportions were shocking. Short, robust hind limbs, dense, compact bone with little of the hollow, air-filled structure seen in other theropods, and nostrils positioned far back along the skull, an adaptation that would have let Spinosaurus breathe while its snout remained partially submerged, much like a modern crocodile. The most dramatic discovery came in 2018 and 2020, when Ibrahim's team returned to the exact same quarry in Morocco and recovered something extraordinary: the missing tail of specimen FSAC-KK11888. Published in Nature in 2020, the tail revealed a structure never before seen in a dinosaur. Instead of a stiff, straight appendage used for balance while running, Spinosaurus possessed a tall, flexible, fin-like tail, supported by exceptionally long neural spines and chevrons, creating a paddle-shaped surface. Researchers tested a physical model of this tail in a flow tank, comparing its propulsive efficiency to the tails of crocodiles and aquatic newts. The result? Spinosaurus's tail generated far more thrust in water than the tails of land-dwelling dinosaurs, strongly supporting the idea that this animal spent significant time actively swimming, not merely wading at the water's edge. Even the feet tell part of this story. Some researchers have pointed to the flattened, elongated pedal bones and robust claws as further evidence of a foot suited to both moving through soft riverbank sediment and, potentially, paddling. No feature of Spinosaurus captures attention like its sail, a row of neural spines rising over 6 feet tall along its back, some of them thin-walled and slightly curved, unlike the thick, rounded sail spines of the North American Cretaceous dinosaur Tyrannosaurus. What was it for? Paleontologists have proposed several hypotheses. One suggests thermoregulation, absorbing or radiating heat, similar to ideas once proposed for the pelycosaur Dimetrodon, an animal unrelated to dinosaurs but famous for a similar structure. Another proposes visual display, used to signal to rivals or potential mates, since the sail would have made Spinosaurus instantly recognizable at a distance, even partially submerged. A third hypothesis suggests the sail may have stored fat reserves, similar to a camel's hump, though the thin bone structure makes this less widely supported. Most current researchers favor display and species recognition as the primary function, while not ruling out a secondary thermoregulatory role. Unlike a shark's dorsal fin, the sail was not a swimming aid. Its bone structure would have added drag, not propulsion. So what did Spinosaurus actually eat? The evidence is direct. In 1917, Stromerr noted the conical, unserrated teeth were better suited to gripping slippery prey than slicing meat, a strong indicator of piscivory, a fish-based diet. That prediction has since been confirmed. Isotopic analysis of Spinosaurus teeth, published by paleontologist Romain Amiot and colleagues in 2010, found oxygen isotope ratios closer to those of turtles and crocodilians than to land-based theropods, evidence consistent with a semi-aquatic lifestyle. fossilized fish scales, including those of the giant coelacanth Morsonia and the sawfish-like Onchopristis, have also been recovered from the same chem beds, confirming Spinosaurus shared its river system with prey large enough to justify a 9-meter predator.
Spinosaurus lived alongside other giant predators in this ecosystem, including Carcharodontosaurus and Deltadromeus, but its body plan set it apart from both, an animal that had, in evolutionary terms, largely left the land-based predator niche behind and moved into the water. The science of Spinosaurus is still evolving. Some researchers have challenged aspects of the semi-aquatic model, questioning bone density measurements, or proposing the animal was more of a wading, shoreline hunter than a true swimmer. This debate remains active in paleontology today, and new fossil discoveries in Morocco continue to refine the picture. What remains undisputed is this. Spinosaurus aegyptiacus was the largest predatory dinosaur ever documented. Its body was unlike any other theropods, and it represents one of the most successful natural experiments in shifting a giant land predator toward a life in the water. From a single destroyed skeleton in a Munich museum to bones bought piece by piece from a fossil dealer in the Moroccan desert, the story of Spinosaurus is a story of scientific persistence, proof that even a ghost dinosaur can be brought back from the edge of extinction in our own understanding. If you enjoyed this journey into the deep past, subscribe for more evidence-based dinosaur documentaries, and let us know in the comments which prehistoric predator we should uncover next.